Mecca isn't just a city. It's the epicenter of the Islamic world, a place where history and holiness are woven into every stone. But in the early 2000s, it became the site of one of the most audacious, high-stakes engineering pivots in human history. We're talking about the Makkah Royal Clock Tower, a building so massive it defies easy comparison, looming over the sacred city at 35 times the size of Big Ben. It's a $16 billion triumph of engineering that serves as a luxury hotel, a cultural icon, and the world's largest clock. However, the version of the tower you see today wasn't the one the world was originally supposed to get. Construction officially kicked off in 2002 with a relatively modest goal, a 450-meter skyscraper that would have still been the tallest in the world at the time. It was meant to be a commercial powerhouse to support the $12 billion annual religious tourism industry that fuels the kingdom's economy. But as the concrete started to pour and the floors began to rise, the project's identity underwent a radical transformation. The Saudi client wanted more than just a hotel. They wanted a spiritual beacon, a grand minaret that could function as a unifying symbol for millions of Muslims. This decision changed everything. The plans were redrawn mid-construction to push the height to a dizzying 600 meters. This wasn't just a matter of adding a few extra floors. It was a fundamental shift in purpose. The tower was now tasked with housing a clock that would establish a new time standard for the global Muslim community, allowing for synchronized holidays and prayer times across the planet. But there was a massive $16 billion problem looming in the heat. By the time the call was made to go higher, the building was already half finished. The engineers were effectively trying to change the engine on a plane while it was already thousands of feet in the air. In the world of civil engineering, you usually have the luxury of knowing exactly how heavy your building is going to be before you ever break ground. You calculate the load, you survey the soil, and you pour a foundation designed to hold that specific mass for the next century. But the Makkah Royal Clock Tower was an engineering anomaly from the start. By the time the decision was made to transform this structure into a 600-meter-tall grand minaret, construction wasn't just underway, it was halfway finished. The concrete was dry, the rebar was set, and the foundations were well and truly laid. This created a foundation trap that would have terrified any structural firm in America. The original footings had been calculated for a 450-meter tower, not the 600-meter behemoth the Saudi royals now envisioned. The engineers were handed a structural ultimatum. They could add 150 meters of height, roughly the size of a 40-story building, but they had to do it without significantly increasing the weight of the structure. To understand the absurdity of this math, you have to look at the numbers. The weight of the additional 150-meter extension, plus the massive clock and the spire, was capped at a measly 82,000 tons. For context, the Shanghai Tower, which stands at a comparable 632 meters, weighs a staggering 575,000 tons. The Saudi team was essentially being asked to build a skyscraper extension that weighed about 1/7 of what its global peers would for the same height. Engineers from the German firm Meyer Luda and Partner were brought in to perform a structural autopsy on the existing work. They frantically checked the reserves of the foundations already in place to see exactly what forces they were calculated to hold. In Mecca, construction standards are notoriously conservative because the city has to handle the literal weight of millions of people moving through the city simultaneously. The engineers discovered that the builders had, luckily, over-engineered the base to be on the absolute safe side. They found just enough structural reserve to allow for a growth spurt, but only if they used materials that were practically as light as air. It was a $16 billion gamble. If their math was off by even a small percentage, the world's most expensive building would begin to sink into the desert floor. Every extra ton added to the top was a potential death sentence for the structure below. This wasn't just weight loss for aesthetics, this was weight loss for survival. When modern engineering hits a wall, sometimes the only way forward is to look backward. Faced with a weight limit that would make a balsa wood model blush, the team at the Makkah Royal Clock Tower realized they couldn't rely on the heavy, concrete-poured methods of the 21st century. To save this $16 billion investment, they had to pull a play from a 19th century playbook, specifically the one written by Gustav Eiffel in 1889. Back when Eiffel was planning his iconic tower for the World's Fair, he faced a similar physics nightmare: how to build the tallest man-made structure in history without it sinking into the soft Parisian soil under its own massive weight. His solution was the now legendary raw iron framework structure, a design that allowed the tower to soar while redistributing its weight strategically downward to its base. The engineers in Mecca essentially performed an Eiffel Hack. They sketched out a plan that placed the principles of the Eiffel Tower right on top of the existing hotel. But instead of 19th century raw iron, they utilized high-strength steel and concrete, maintaining that iconic framework philosophy. This wasn't just a stylistic choice, it was a structural necessity. By moving away from solid, heavy walls and toward a slender, latticed framework that grew more tapered as it rose, much like the trunk of a tree, they were able to shed the dead weight that would have otherwise crushed the foundations below. This lightweight skeleton was then carefully positioned on 5 massive transfer slabs on top of the original concrete hotel structure. It was a brilliant, albeit risky, adaptation of industrial-age genius applied to a space-age megaproject. By mimicking Eiffel's lattice approach, the team managed to create a 600-meter profile that had the visual impact of a mountain, but the structural footprint of a featherweight. It was a masterclass in architectural liposuction. They kept the height, they kept the grandeur, but they ditched the tonnage that threatened to bring the whole house of cards down. In the high-stakes world of Saudi megaprojects, looking back to 1889 wasn't a retreat. It was the only way to reach the future. In any typical American skyscraper, every square foot of floor space is a commodity. If you're building in the middle of a high-density urban core like Mecca, the most congested area in Saudi Arabia, you generally want to maximize your square footage to get the best return on investment. But the Makkah Royal Clock Tower had to play by a different set of rules. To keep the building from exceeding its 82,000-ton weight limit, the architects had to perform what can only be described as architectural liposuction on the interior of the extension. This led to the creation of the voids. If you were to step inside the upper reaches of the tower, you would find yourself in a space that feels more like a cathedral than a hotel. Behind the massive clock faces, the distance between floors jumps to a staggering 12 or 13 meters. In a normal office building, that would be 3 or 4 separate stories. Here, it's just one giant cavernous level. And it wasn't just about height. The floors themselves are physically cut out. Large sections of the floor plates are simply missing, creating massive voids where there would usually be thousands of tons of concrete and steel. This wasn't an aesthetic choice made by a minimalist designer. It was a desperate move to shed tonnage. By hollowing out the building, the engineers were able to maintain the tower's massive, imposing silhouette while drastically reducing its actual mass. It's a clever bit of visual deception. From the outside, the tower looks like a solid, impenetrable monolith, but the higher you go, the more it resembles a hollowed-out shell. To prevent these spaces from feeling like wasted, empty industrial zones, the designers incorporated them into the building's cultural mission. These massive voids were transformed into exhibition spaces and galleries for large-scale artworks and historical exhibits. It was a brilliant pivot that turned a structural necessity into a luxury feature. The building needed to lose weight to survive, but in doing so, it gained a sense of internal scale and grandeur that few other buildings on Earth can match. Every empty cubic meter of air inside those upper floors represents weight that didn't have to be supported by the foundations below, ensuring the weight loss plan remained on track without sacrificing the tower's 600-meter ego. If the building's body was on a strict diet, the head, the massive, 4-faced clock, had to be a miracle of lightweight materials and aerodynamic survival. Building the world's largest clock at a height of over 400 meters meant dealing with wind speeds that can scream across the desert at 200 kilometers per hour. At that altitude, the clock hands aren't just telling time, they are essentially giant sails. And if they weren't engineered correctly, the wind could literally rip the face off the building or snap the internal drive mechanism like a toothpick. To solve the weight versus strength crisis, the engineering team at Perro, a German specialist firm, ditched traditional metals for the hands. Instead, they utilized high-tech carbon fiber, creating minute hands that stretch 23 meters long. For an American audience, that's roughly the length of 2 school buses parked end to end. Despite their size, these hands are so lightweight that they can be operated by a centrally installed clock drive. They even designed the hands to be hollow, allowing maintenance workers to literally crawl inside them to perform repairs 600 meters in the air. But the real weight loss genius was in the clock face itself. Traditional flat faces would catch the wind like a billboard. Instead, the engineers designed a slightly concave, or dished, profile. This curvature ensures the clock hands stay within the aerodynamic profile of the building, shielding them from the brunt of the wind pressure. This dish wasn't just for aerodynamics. It also allowed the clock to be seen from over 8 kilometers away. Finally, the lighting had to be considered. Using traditional glass and heavy bulbs was out of the question. Instead, the team used a staggeringly high-tech array of over 2 million LEDs. These weren't just any LEDs. They were specifically developed to withstand the blistering Saudi heat, which can dramatically reduce the lifespan of standard electronics. By spacing each LED pixel exactly 105 millimeters apart, they created a solid green glow that provides a sharp, legible image at a fraction of the weight of a traditional illuminated sign. It's a $16 billion masterclass in how to make the heaviest-looking object on Earth practically float. While the engineers were busy shedding tons from the blueprints, the logistics team was fighting a war of sheer volume. To cover a building this massive, the architects didn't just want paint. They wanted a mosaic of 98 million tiles. The order was so immense that the Venetian company selected for the job a firm used to the slow, artisan pace of high-end glasswork faced a production crisis. At their normal rate, they could only churn out about 15 to 20 square meters of gold tiles a month. At that speed, the tower wouldn't have been finished until the next century. The solution was a sudden leap into the future. The company had to co-develop a robotic system to automate the manual tile-laying process, cranking production up to 300 square meters a month just to keep pace with the Saudi construction schedule. But making the tiles was only half the battle. Because of the strict religious access laws in Mecca, much of the tower actually had to be prefabricated in Dubai. The 98 million tiles were shipped there, painstakingly hand-applied to facade panels by over 100 specialists, and then loaded onto trucks for a grueling 3-day journey across the desert to the site. It was a $16 billion assembly line that stretched across international borders. The weight loss plan faced its ultimate test during the installation of the Grand Minaret's crown, the Crescent Moon. This structure alone contains 3 floors, including the highest prayer room on the planet. As the crane lifted a 7-ton segment of the crescent to the 600-meter mark, the team realized they were operating at the absolute mechanical limit of their equipment. The tower crane's tip was barely high enough to reach the platform, and the weight of the segment sat exactly on the crane's maximum capacity limit. Then, the wind arrived. At 600 meters up, the crescent began spinning out of control, making the riggers on the structure physically ill from the motion. It took a harrowing, high-altitude struggle with ropes and a frantic crane operator to finally pin the weightless giant into place. It was a moment of pure adrenaline that proved even with the best weight loss plan, physics always gets the last word. The 2012 opening ceremony was the culmination of 3 years of hardcore pressure and stress, marked by the moment the King of Saudi Arabia pressed a symbolic red button to ignite the tower's 2 million LEDs. This wasn't just the completion of a building, it was the birth of a 600-meter icon that now gives its own time signal to Muslims worldwide. Despite its $16 billion price tag and record-shattering stats, the tower remains a bit of an enigma in the West. Some of the very architects who spent years obsessed with its weight loss have never actually seen their work in person because they are non-Muslims, restricted from entering the sacred city. Yet, for the engineers and the 17,000 workers who poured their lives into this grand minaret, the anonymity in Western magazines doesn't matter. The real value lies in its unification purpose, functioning as a high-altitude beacon that is slowly being metabolized by the city's ancient identity. It stands as the highest occupied man-made space on the planet, with its prayer room and office sitting inside a carbon fiber crescent that towers over everything else. The Makkah Royal Clock Tower serves as the first real proof of concept for the Saudi megaproject era. It proved that you could take an impossible set of constraints, a half-finished foundation, a 600-meter height goal, and a strict weight limit, and solve them with a mix of 19th-century logic and 21st-century robotics. It's a towering accomplishment that proved the kingdom could build the impossible, as long as they were willing to put their architecture on the ultimate diet. As Saudi Arabia looks toward even more ambitious desert cities and arenas, this $16 billion weightless giant remains the blueprint for how to reach for the sky when the ground tells you it's impossible.